Hello, this is part 2 of section 8.3. So now we're going to be testing for independence. The requirements are simple, random samples, independent subjects, and all expected outcomes greater than or equal to 5. So far it looks very much like the test for homogeneity. This is the main difference, is now instead of saying the proportions are all equal to each other, the null hypothesis is that the two categorical variables are independent. And the alternative hypothesis is they aren't. But you will notice that the contingency table and how we calculate the expected values is the same as the test for homogeneity. Even the test statistic is exactly the same. The difference is when you're doing the test for homogeneity, you're drawing different samples and then measuring in each sample. So, in other words, your column totals are fixed. For the test of independence, you're actually only taking one sample, and then for each person in the sample, asking which category they're in for the column in the category. So, in this case, it's the grand total that is fixed. Now, the distribution used is the chi-square distribution. So again, for critical value method, we will use Q chi-square. And for the p-value method, we'll use P chi-square. Again, though, most of the time we are just going to use the R function, chi-square.test, in the data as a matrix, just like with the test of homogeneity. So example 3. When a newborn is HIV positive, should he or she be treated with nevirapine, MVP, or a more expensive drug, lopinavir, LPV? In this context, treatment success means preventing um, virologic failure or the growth of the virus. Researchers conducted a randomized study to investigate a possible association between treatment and outcome. Among the 147 children who received MVP, approximately 41% experienced virologic failure, compared to about 19% of 140 children treated with LPV. Test whether there is an association at a significance level of 0.01. So, um, the test of homogeneity could give you questions like this too, where you have to make your own observed table. So that's the first thing I'm going to do before I check for the requirements. So we have the two drugs. I'll put that in the columns. And then we have VF for the virologic failure and no VF. And then we have the total as well. So 147 received MVP, 140 received LPV. So that means our total was 287. And now I know 41% experience the virologic failure. So 0.41 times 147. Oh, sorry. Typed in 174. So we're getting 60.27, which means 86.73 goes here. And then for the 140, we have the 19%, which is 26.6. So 113.4. And those totals 86.87 and 59.87. Oh, wait, that doesn't make sense. 213, that's better. So now I have my table, but I do want to point out when we type this into R, we are only going to use the observed values, not the total. So is this a simple random sample? Yes. And are the subjects independent? Yes. So now I just need to check to see if all my expected outcomes are greater than or equal to 5. And I'm going to go over to R to do that. So I'll go HIV equals matrix collection 60.27, 26.6, 86.73, 113.4, and row equals 2, and call equals 2. And by row, because I went left to right, will also equal true. Remember, if you go up and down, you choose false. Double check my matrix, make sure I typed everything in correctly. That looks good. And now time to do the chi-square test of my matrix, and then $ expected. Make sure you have that $ expected on the outside of the parentheses. And all 4 of those values are at least 5, so I meet my size requirement. So let's go ahead and copy this so I can paste it into the notes. And go back to the notes. So there we go. So now, what was the claim here? The claim wanted to see if there was any association. So if they're associated with each other, that means they're not independent. So that means the claim would be they are not independent. Which means the opposite would be they are independent. The null hypothesis is always they are independent. And the alternative hypothesis is that they are not. Well, this is a chi-squared test. So I'm going to have a right skewed graph. And just like the test for homogeneity, it's always right-tailed. And what was our significance level? 0.01. Okay, there we go. So now I'm ready to calculate the test statistic. So I'm going to go back over to R. go chi-square dot test of HIV. And then there's our chi-squared value and our p-value. Go ahead and take a screenshot of that and then paste it over here. Now I'm back at the notes. One thing I noticed while pasting this over is it told us it did this with Yates continuity correction. That's when it's specifically a 2x2 table, which we didn't experience in the last test. So if you were to do this by hand, you would get slightly different values, not that much different. But if you wanted exactly by hand values, you would just add correct equals false like we did for the 1 prop and 2 prop test. But in this case, it's not going to make that big of a difference. So I'm just going to leave it with the continuity correction. So our chi-squared value is the 15.418. Our p-value, because of the e negative 0.05, that's basically 0. So our p-value is less than alpha. So we reject the null and support the alternative. And since the claim matched the alternative, we do support the claim. So there is enough evidence to suggest there is an association between treatment and outcome. And then just like we did last time, to figure out where that association is, we go about and compare observed to expected. So let's see here. This is higher, which then automatically means this is lower. This is lower, and this is higher. But they are all pretty much far away from the expected value, which explains the very low p-value. And which one's better to have higher? The no virologic failure. So this is the success. So since this was lower, so it does look like LPV works better. Okay. So example 4. A study examined whether exposure to peanut products reduced the rate of a child developing peanut allergies. Children were randomized either to the peanut avoidance or the peanut consumption group at 5 years of age. Each child was tested for a peanut allergy using an oral food challenge, OFC. The results of the OFC are reproduced in the table below. Failing the food challenge indicates an allergic reaction. Assess whether there is evidence for exposure to peanut allergy reducing the chance of developing peanut allergies using alpha equals 0.05. So our simple random sample checks out. The independent checks out. So I just need to check the size, and we go over to R to do that. So go over to R, erase that. Here we go. I'll just call it peanut equals matrix collection 36, 227, 5, 262. And row equals 2, and call equals 2, by row equals true. Double check and make sure I typed the matrix in correctly. That looks good. And now to get my expected values. And all my expected values are at least 5. Before we even do the test, I do see some differences. I would say the peanut consumption did make them less likely because 5 is quite a bit lower than 20. So my guess is there is going to be a low p-value here. And just so I don't have to come back and I want to do this test, I'm just going to do the test and copy it all over at once this time. And there we go. Like I said, we got a very low p-value. And to even be extra careful, I am going to correct equals false. Still a very low p-value, but just not quite as, actually it's a little lower. So let me zoom this out so I can copy it all. There we go. No. Boom. Oh, something went wrong. Let me try again. There we go. So back over to the notes. There we go. So as I said before, we meet the size requirements. The claim and everything's the same as before, so I'm going to kind of just cheat and copy and paste it. So there we go. And then our type tail test is a right-tailed chi-squared test. And we're using 0.05 significance level. And then chi-squared is, let's just go ahead with the 25.915. The p-value is basically 0. So the p-value is less than alpha. So we reject the null and support the alternative. So basically, there is an association between peanut exposure and peanut allergies later on in life. And comparing the expected values to the observed values, it would seem peanut exposures lowers your chances of getting peanut allergies. And then I will leave the last page of the notes to talk about in class on Tuesday.